Good day everyone. Today we will be talking about vectors. This is part 3 of the vector series, and the first thing we're going to talk about is adding and subtracting vectors. Suppose I have two vectors, AB and BC, and I want to add these two vectors together. I add their column vectors. To do this, we add 4 and -2 together, and then we add 3 and 3 together. So we get 4 plus -2 is 2, and 3 plus 3 is 6. In the same way, if I want to subtract these vectors, I subtract the column vectors. So 4 minus -2, that's 6, and 3 minus 3 is 0. So now we're going to look at the triangle law of vector addition. Suppose I have a vector AB, and then continuing from B, I have another vector BC. The triangle law says that if we add these two vectors together, we get AC, which is 8, -1. Now let's look at what the triangle law says again. It states that when two vectors are represented by two sides of a triangle in the same flow, so that's the vector AB and BC, the addition of these two vectors is the result of the third side flowing in the opposite direction. So the third side would be A to C. So we have AB is 4, 3, and we have B to C, that's 4, -4. So then the triangle law says that AC is equal to AB plus BC. And now this is equal to 8 minus 1. Now when we apply the triangle law of vector addition, we see that A and C are the first and last letters of the two vectors, and B is the common letter between the two vectors. Let's look at an example. The position vectors of A, B, and C are OA 2, -2, OB 6, 1, and OC 10, 4. Find AB. Now by the triangle law, we know that AB is equal to AO plus OB. Again, notice that A and B are the first and last letters of the addition, and O is the common letter between them. AO is the same as -OA. If you can't remember, please review inverse vectors. And now we have plus OB. And this is equal to -2 minus 2 plus 6, 1. When we simplify the first vector, we get -2, 2. And then when we add it, we get 4, 3. So AB is equal to 4, 3. Now let's look at example 2. We have the same question, but we want to find AC. Again, by the triangle law, AC is equal to AO plus OC. Notice A and C are the first and last letter, and O is the common letter that is positioned between the two vectors. Again, AO is -OA plus OC. This is equal to -2 minus 2 plus 10, 4. And this is now -2, 2 plus 10, 4, which is equal to 8, 6. So now we're going to look at the parallelogram law of vector addition. Suppose I have a vector AB and another vector AC, which flows in a different direction to AB. Then the parallelogram law of vector addition tells us that when we add AB to AC, we will get the diagonal of the parallelogram formed. So if we draw a parallelogram, we'll get something like this. And then the diagonal of the parallelogram would be AD. So when we add AB to AC, we get AD. So the law states that when two vectors of opposite flow, which was AB and AC, are represented by two adjacent sides of a parallelogram, the addition of those two vectors is the result of the diagonal of that parallelogram, right? So we know that AB is 4, 3, and AC is 8 minus 1. So when we add these two vectors together, we get 4, 3 plus 8 minus 1, which is 12, 2. And as you can see in the diagram, we go 12 units to the right and 2 units upwards. Displacement vectors. Suppose I have an object A and the image A prime, then the displacement from the object to the image is simply this vector from object to image. So we go across 5 units to the left, and then we go downwards 9 units. So the displacement vector from object to image would be -5, -9, right? So the displacement vector is a vector formed from the initial position, which was the object, to the final position, which was the image. So we have A to A prime is equal to -5, -9. Collinearity. 3 or more points are said to be collinear if they lie on a straight line. Suppose I have 3 points A, B, and C. For these points to be collinear, a straight line must be drawn through them. So we see that these points are collinear. Let's look at another example. Suppose I have 3 points D, E, and F. For this to be collinear, a straight line must pass through these 3 points. And here we can see that it is not collinear because the straight line does not pass through E. So how to show that 3 points are collinear? The first step is to choose any 2 vectors using the 3 points. So it can either be AB and AC, or we can choose AB and BC. And for the second step, we must show that the gradient of the 2 vectors that was chosen in step 1 is the same, and also it must have a common point. So for example, in AB and AC, the common point was A, because we have A in 2 of those vectors, and in AB and BC, the common point is B, because we have B in both of these vectors. Example 1, we had found AB and AC using the triangle law, and we had gotten 4, 3, and 8, 6. So the second part says, determine if A, B, and C are collinear. The first step, we choose 2 vectors. We already have A, B, and AC. So we find the gradient of these 2 vectors. The gradient of AB would be 3, 4, and the gradient of AC would also be 3, 4. Now, since the gradients are the same and they share a common point A, the 3 points A, B, and C are collinear.